Hello everyone, my name is Toni. I'm with the Applied Research Group at the Ethereum Foundation. And today I want to talk about a topic that is very important to me and I guess also very important to the broader Ethereum ecosystem, very important to many of you, which is decentralization. Before I get into my talk, just a rough outline what I'm going to talk about. I want to start with a quick recap on attestations. Why do we need attestations when it comes to Ethereum's consensus? What are attestations and why are we attesting? Second, I want to quickly outline one of today's problems. And finally, quickly introduce an EIP, EIP 7716, why we need it and make the case for its inclusion in a future hard fork. So let's get started. As said, a quick recap on attestation. So validators on the Ethereum blockchain attest to blocks in order to kind of coordinate on the canonical blockchain to agree on what is the latest block and what is the block to finalize. And technically, an attestation contains of three things: a source vote, a target vote, and a head vote, where the source and the target vote are mainly used to finalize certain checkpoints in time, and the head vote is used to agree on what is the latest block that we see as canonical, as confirmed, and that the next proposal builds on top of. Validators have an incentive to attest because they receive rewards for correct and timely attestations, and on the other hand, if validators don't attest, they receive a penalty. Here, a quick image of how attesting works. So as the example here shows, if you're the attester in the first slot of an epoch, then you basically place your source vote to the previous epoch, your target vote goes to the first slot in the current epoch, and your head vote is pointing to the latest block, to the latest slot that you see as valid. Of course, this assumes no reorgs, no missed slot, but it's good enough for simplicity here. Right, so let's get into the problem. And the problem is solo stakers are struggling today. Why is that the case? So what you can see here on this bar chart is a comparison of professional node operators like Kiln, like ETHFi, Lido, and so on. And on the other hand of the spectrum, we see solo stakers. And what the chart shows is the expected missed head votes over time compared to the market share of the respective validator. And if we focus on the very left-hand side of the chart, we can see that those professional node operators, they have a great performance, so they don't miss attestations, and for most of the times they attest correctly. On the left-hand side, on the right-hand side, we can see solo stakers, and solo stakers are basically, from a performance perspective, the worst, right? Solo stakers struggle with attesting correctly and timely. And this is kind of expected because solo stakers are known to be those small entities that run some node from their home base. They might have power outages, have no backups, they might have to fix their node at some point, they might go on holiday. So there are many reasons why it is expected that solo stakers perform bad. On the other hand, solo stakers are super important because there are situations, for example, a 51% attack, censorship, and so on, where solo stakers are super important. So while solo stakers are performing worse than professional node operators, they are very, very important to allow Ethereum to achieve its mission. So what is the problem here? Staking comes with centralizing forces. And this is kind of inherent to Ethereum today. There are those centralizing forces that we continuously need to fight against. And those centralizing forces, they originate from one very hard to defend thing, which is economies of scale. So economies of scale, many of you might have heard of that phrase, is basically if you can reduce your costs just by scaling up the operation. And of course, solo stakers cannot do that. Professional node operators, they can. And when we look onto Ethereum staking today, then we get something like this picture, where the more validators that you run, the lower you can push down your costs. And if I had to show you where solo stakers are, they are on the very left-hand side of this curve, while the professional node operators are on the right-hand side of this curve. So the professional node operators can push their costs down, while the solo stakers cannot really leverage economies of scale. On this table, you can see a quick example how economies of scale play out in Ethereum today. Just comparing solo stakers with, for example, Coinbase, and we can see that then, even though they both run one device, one machine, which is in this case, just as an example, an Intel NUC, we can see that you can run thousands of validators on one machine, right? This, of course, comes with increased costs. For example, you have to pay higher bandwidth, you might need more electricity, but in the end, what we can see here is the Coinbase box, so the Coinbase machine, would make 1,000 times more profits than the solo staking box. On the other hand, the costs are not 1,000 times more. And this is exactly what I mean with economies of scale. Coinbase can operate much more efficiently than the solo staker. And of course, having your validators run from one machine is not the only source of economies of scale. You can use one cloud service provider, ISPs, the geographical location, client software, but also the maintenance responsibilities are sources for economies of scale. For example, one solo staker might manage one validator, whereas a professional node operator might have a team of 10 to 20 people managing hundreds of thousands of validators. So the question is, what can we do against that? What can we do to improve the decentralization that is kind of in staking in the situation where kind of those centralizing forces push us towards centralization? One thing that is very important here is economies of scale don't come without correlations, which means if you put thousands of validators on one box, those validators behave in a very correlated way. For example, if you have a power outage and the box goes offline, all your 1,000 validators will be offline too, right? So you have a high correlation between those validators. And this is very important to understand. You cannot really leverage economies of scale without also creating high correlations between your validators. And the goal of Ethereum must be to reduce those correlations. For example, if Google goes down or if AWS goes down, the Ethereum network should not suffer, right? We should have an uncorrelated network that ensures that even if something happens that is an external factor, like some cloud service provider going offline, we want Ethereum to still continue as normal. So the goal must be to reduce correlations on every front. And then what we get is basically on this picture you can see we will go onto the left path, so we want to go towards diversity when it comes to the staking setup. We don't want to have homogeneity when it comes to staking, because then we open ourselves to those external threats that are very bad, right? We don't want to have all node operators in one country, because if something happens in that country that affects stakers, then things can go bad very quickly. And now, this is the potential solution, EIP 7716, anti-correlation attestation penalties. The EIP itself is very new, so as you can see in the date created, it's 2 months old now. It was created by Deadline, Vitalik, and me. We improved it at the ETH Berlin hackathon. So all of the ideas I'm presenting now are still very new, so keep that in mind. The EIP itself is called anti-correlation attestation penalties, and the goal of it is basically to introduce an increased penalty when you're correlated a lot with other validators, and decrease the penalties if the correlation is low. And getting back to our economies of scale curve, this should kind of be the outcome that we want to achieve through that Ethereum improvement proposal. We want to get that economies of scale curve down, flatten it, so that the solo stakers has the same economic benefits than the big node operators. Here is a quick example. We see two boxes. This can be two machines. One of them runs a lot of validators. The other one has only one single validator. And the thing is, if the box with the many validators goes offline, then we see a high correlation, which means we want to see a high penalty for all of those validators in that box. On the other hand, if the box with only one validator goes offline, then the correlation is very low, and we can also set the penalties very low. So the EIP basically proposes to scale penalties based on the observed correlations within the network. Here you can see some initial results from some analyzers we did a few months ago. And what you can see here is that introducing EIP 7716 would lead to small entities getting less penalized, while big entities will be penalized more. And this is exactly how to counter economies of scale. So here you can see the small size clusters, which include solo stakers. They would have had less penalties than compared to the current situation, while the large size clusters, they would face larger penalties. And this is purely because they are leveraging economies of scale, thus creating high correlations within their setup, and then getting higher penalties. This brings me to the open question. As said, the EIP is still very, very new, so there are still many open questions that we have to answer before we can ever ship that EIP. First of all, one open question is, do we want to apply anti-correlation penalties only to the source vote, or do we want to apply them to all parts of an attestation? So also include target votes, also include head votes. There are some arguments for only doing it for source votes, because for source votes, you're very independent from external factors, for example, the slot index within an epoch. On the other hand, in my opinion, I think we should do it for all parts of the attestation, just because even if there are some external factors like timing games and so on, in the long run, we should see the positive effects of anti-correlation penalties playing out, no matter if it's only the source vote or we also including the target and the head vote. Next, the exact mechanism and the constants. If you look up the EIP today, you will see it's in a very, very drafty stage still. So there are some constants that we will have to set, and I invite every one of you to engage in the discussion, help us find the right values, find the right mechanism, how to introduce those anti-correlation penalties. And finally, of course, there's a question, when can we ever ship such a change? It might be too late for the Pacture hard fork by now, but the goal must be to ship it in the fork after Pacture. But in the end, it's of course the community, every one of us who participates in the discussion, who voices that such a change would be important, should be prioritized, that in the end pushes the EIP towards being included in some future hard fork. Finally, let's together make Ethereum more decentralized. Please engage on Twitter, voice your concerns. If you're a solo staker, tell us how you're doing, if it's hard to keep up with all your duties. And also engage in the discussion on Twitter, Farcaster, on social media, and so on. Because if it's not the community that says we want to have such a change, then such a change will simply not happen. Second, I invite everyone to contribute. You can find below on ETH Magicians, for example, you can find all the links on our GitHub. So my GitHub is in a relation. You will find many links there. You can find a Lighthouse implementation. You can find implementation into the Ethereum consensus layer specs. And also on ETH Research, if you want to analyze the whole thing, please engage, reach out to me. I'm happy to help you. And together we can then analyze the whole thing. How would it change? Which effects would it have on solo stakers? And in the end, kind of add some weight to the whole proposal by showing the potential impact it would have. Yeah, and here you can also see my Twitter name. It's the same on Telegram. Please reach out if you have any questions. I'm always happy to help you with that. And this is it. Thank you very much.